Bless you.
Michael, how are you?
Very good. Very good.
Very best wishes for 2024.
Indeed. Happy New Year. This is
Yeah,
the year of Jinaga going public.
that's a great idea. But it's
Mm-hmm.
it's almost halfway the year. No, it's almost halfway January,
Mm-hmm.
not 2024. I saw you got some nice videos recorded.
Ah, yes, yes.
I saw the first one, I saw the second one. The third one is still where apparently you did some other magic to the UI.
Mm-hmm.
That one I haven't seen yet.
Yeah, that one was a lot of fun. Yeah, the example that I built real quick to show um, the real time push, the real time
Mm.
updates of the UI. Um, that was as the title says, a terrible chat app, and so yeah, I wanted to go through and make it not terrible, and ran into three different bugs. That was good. Got found those and got those fixed.
Because in the second one, you posted the message in one
Hmm.
and he updated immediately in the second one.
Yes, yes. So I was showing that core feature, but
Mm.
yeah, there's a lot of things wrong with that particular chat app. But the most important being that there's no security in it, so it doesn't even know who a user is. It doesn't know who
Mm.
posted what.
Okay.
Um, so yeah,
I'll
we're working
have
toward
a look
that.
at that video. I'll have a look at that video.
Excellent. Yeah.
3 minutes ago, I sent you the notes on the chapter 4.
Oh, excellent. Thank you.
That was just before
Hmm.
logging in. Actually, there was a few remarks, but it's always the same thing. And I think it's my English.
Hmm.
Uh, it's not my mother language, but it sounds very funny to me. Like, for example, a customer must decide to eat at a restaurant because they saw an ad. This singular plural thing. A customer, singular,
Hmm.
must decide to eat at our restaurant because they saw an ad. They saw.
Oh, okay. Right. Yes.
Yeah.
Yeah.
And, and,
Um,
and they is plural.
hmm Yeah, that is actually something that the editor changed in the first edition, and so I kept that nomenclature. So they I had used gender specific pronouns, and in English uh, the only singular pronouns are gender specific.
Yeah.
So I
His
chose
and her.
genders for different for different
Yeah.
uh, uh, roles, and so they changed them all to gender neutral pronouns, which also happen to be plural. Um, so yeah, I remember when I was growing up, the way that I was doing it, that was what I was taught in schools. But we've uh, we've changed we've changed our direction on that. So now we're um,
Okay, so now they're using they as a singular form,
yes,
which is gender independent.
yes,
Okay,
yes.
because I found it in a few places in that chapter, and it's really confusing.
Hmm.
Uh, it's like I listen to my wife. My wife is Chinese,
Hmm.
and so she will be talking about me, and she will say, Jan with her friend.
Hmm.
I say, no, Jan, his friend, not her friend.
Hmm.
But that seems to be typical for Chinese. They mix his and her.
Hmm.
Um, but now I see it in English, and it's
Yeah.
um, yeah,
Yeah, there was a time I remember when people were trying to decide should we add a gender neutral singular
mm,
pronoun to English, and I actually saw I can't remember what they were, but a few examples, a few suggestions that people put out there, and
mm.
they didn't catch on. Basically, the underlying opinion now is that well we've already got a pronoun. Let's just change what it means and keep moving forward.
Well, if that's what is accepted,
Mm-hmm.
I will I will live with it. I never thought. I, I don't remember. I saw that in the first edition. Um, Perhaps I just never read it well. No, I think for the rest there was one sentence where it looks like you forgot an if, but for the rest, okay.
Okay.
And
Yep.
then the videos, it's getting more and more complicated.
Uh-huh.
That one on immutable runtimes. Yeah, that was
Mm-hmm.
also in chapter 6. In chapter 4, you spoke about search,
Mm-hmm.
which is one of the problems in historical modeling.
Right.
And then in 3 weeks ago in the video you recorded, you spoke about an indexer.
Yes.
So that indexer was based on a separate replicator.
Correct. Yes. So yeah, the replicator still is in the immutable part of the application. So it's still talking about the historical model, but then it's integrated with a stateful search engine, and so that there's a lambda. So literally, it could be a lambda function, or it could just be a service that's constantly running and reading from a queue, a historical queue, in order to call the indexer and index the information coming out of the historical model.
I see two problems with search. One problem is that you don't have all the information. It's a distributed system, so you might miss some information, but there is nothing you can do about that. The second problem that the historical model, the specification language, is not SQL, so it's not powerful enough to search on fields.
Right. Yes. Yes.
So is it that second reason that you want to solve with that separate lambda?
It really is both of them. Yeah, I can't really say that's. Well, yeah, I think really the second one. You're right. Yeah, the second one is probably the more important, because somebody might say, well, you've got the central hub of replicators, and so why not expose the like the read endpoint to the outside, and you can say, oh, I'm just going to read something, and then give the replicator, specifically the read endpoint, the capability of searching by by a field, it was really that the data structure that I'm using for the replicator is just a graph. It's the same graphs that I draw throughout the book, but just represented in the database. That graph is not optimized for search by field, and so I said, well, let's move the data to something that is optimized for that.
So that index might, for example, be a SQL database, where, as the facts come in, it populates the database, and to search we run a SQL query.
Yes.
And then how do we access that data from the client?
Yes. So
because the result has to be fed back in one or the other way. That might become a feed then, but then we need a new syntax for the specification language to allow that search.
I foresee the search being done via a completely different API. So it's not through the specification language, and it's not something that you express to the Jinaga library at all. So it's not part of the specification language. So instead you call an API, so it could be that you stand up your own front end server, using the traditional methods that we already use and that hits the SQL database, or maybe you can expose the search engine to the internet if you have it properly secured. So don't know of any search engines that actually recommend doing it that way, but if there was one, that might be a good choice. All the writable side is inside the network, but we expose the read-only endpoints. You'd still want to secure the data from your search index. So you'd still want an API that knows your authorization rules and that sort of thing.
We'll see where we get for that one when we need it. Then there was this shared project pattern and the enterprise level sharing, which is not getting easier. I find it quite abstract. Because the purpose of having this team level shared project is just of having the owner of the project going away, leaving the company.
That one. I'm sorry that I'm also over here making sure that the YouTube stream is working. Okay. Authenticating that. All right. So the idea there is that there's a different pattern for somebody that owns a project because they created it versus somebody that can administer a project because they were invited to do so. And so you end up with two different forms of authorization rules. And so if you have to carry those two different forms of authorization rules through the whole thing, then it makes a bit of a mess. But more importantly is that revocation works on the second one, but not reliably on the first one. You can try, but that would actually there's a little case you can get into where you could actually lock out the entire thing. But it's really that asymmetry between the two that maybe say, okay, I really need to make this a one-time thing, and it's only used for authorizing the first administrator, and then from that point forward, administrators authorize other administrators.
Okay. Well, it's a very clever finding.
Yeah, that one took me a little while. I made the mistake the first time through of the first time I did this of using an actual the managed user as the owner, and that's how the Improving You app worked. So there was my user ID, and then there was, or user fact, and then there was the company. So it's like, Michael is the owner of Improving. Well, that's not actually accurate, but that's the way that I had to model, because I was the one who was logged in when setting up the data structure. And then all of the authorization rules were somebody is authorized to create this fact if they are the owner of the company or if they are an administrator.
You have to double everything.
Yeah. And then not to the extreme of leaving the company, but I did hand over administration of Improving You and the Improving You app to my successor, and so I was able to make him administrator, but I actually did put in a mechanism to revoke my own access, but I never actually used it because I recognized that might cause a problem. So so I had a successor fact to company that was called not revokes access, but you know, kind of the opposite of retains access. I forget what term I used, but that the owner has given up administration of this company, and so then the authorization rule was, if they're the owner and not exists this revocation fact. So that was the authorization.
Access expired.
Yeah, yeah.
Yeah.
And so I coded that in, and then that was also the authorization rule of administrators. So if access expired, then I can't create another administrator and assign that to somebody else, but administrators could. And then I got to realizing that if I were to bring on a new replicator and start to feed this data into it, then because there's no causal connection between access expired and the administrator facts, it's possible that access expired could arrive first, and then all of the administrator facts would be not authorized.
Okay.
So that's that would be a problem. Basically, you'd say, nope, nobody is an administrator of this company, and then all of the subsequent facts that look to the authentication or the authorization rules. Like, oh, an administrator must do this. Well, let me take a look at the signature. It's signed by this person, but no, they're not an administrator, so I reject that fact. And that, you basically replicate and then end up with an empty database. It's like, what happened here?
And that's where you start looking for this new pattern.
Yes.
Okay.
Yes. So it's a bit confusing, but it's the kind of thing that that the math kind of leads you into, and so just have to follow the math.
No, I have the impression that the second edition is not just going to be the first edition with some corrections. It's almost entirely new.
Yeah.
Because even chapter 4 is new. Chapter 5 is a complete rework. I haven't gone through it completely yet, but it's a complete rework.
Well,
you spoke about chapter 6 is also completely new.
Yeah, chapter 6 is completely new. 4 and 5 swap positions, but there are some updates to both of them.
They are quite.
Yeah, and in fact, that decision, I was kind of struggling with the order of chapters 4 and 5, even with the first edition, and decided to go with with having the basically the math heavy chapter first, and then doing analysis later, because I wanted analysts to understand the the motivation behind analyzing things this way. So I said, okay, let's get through the math, but I wrote that in such a way that you could, once you got a little bit deep in the math, and you're like, okay, I get it. Yeah, I don't need the proof. Then you could jump to the next section at the very least. But that you would have that exposure to CRDTs and to idempotent and associative and commutative operations before getting into, well, this is how you can now analyze a problem using immutability that now takes advantage of those things. But then as I was really going back through it a second time, I realized I had made the case earlier on. So chapters 1 and 2 make the case for why you would want immutability in the first place. And that was intended to be at the executive level. So an executive can stop reading after chapter 3. Chapter 3 is really just there for them to be able to communicate with their tech team in order to discuss things historically. But they could read chapters 1 and 2 and say, yep, this is the thing, buy a copy for all of their team and say, we're doing this. but yeah, I wanted the analysts to to be able to stop reading after chapter 4. So move that that data up, or move that chapter up, and gave them an off ramp. And so
Well,
yeah.
I think that the sequence that you have now is very nice.
Good, excellent.
Yeah. And there were quite a few new details in chapter 4 as well.
Mm-hmm.
It was much more structured, I find, than that it was before.
Yeah, yeah, yeah. And I think a lot of those ended up being just small changes, but having a big impact. But yeah, as you said, chapter 6 is completely new. So that was as I went through in the video, basically taking the idea of the immutable runtime that was hinted at through the first edition, and then really explicitly given in the last chapter of the first edition, and say, okay, let's give this its own place. Let's really talk about what you can do if you've got an immutable runtime. And that was the earliest that I could put it, because you needed all of that context in order to to really get it.
You made me very fascinated about chapter 6, but I first have to read chapter 5 here,
Mm-hmm.
complete that one. So I'm gonna try to finish chapter 5 this week.
Yep. That's the
I
one
had
with
a
all the maths in it.
I had a month to finish it, and I even didn't finish it.
Mm-hmm.
Yeah, so many things to do.
Yeah. Yeah, that one's still my favorite chapter. It's in the first edition, that was it was chapter 4, and that was the first one that I wrote. So like, let's start right here with the meat of it, and so got to go back through all of my favorite math papers, and then explain the those results to to everybody else. So that's still a lot of fun.
But you really see that by reading through the second edition that the project is much more mature now than
Mm-hmm.
it was at the time.
Yeah. Yep.
But,
Yeah, and that's really coming out with right now. I am writing chapter 12, and chapter 13 I'll be starting next week. Actually, I might even be able to get started on chapter 13 this weekend if I get chapter 12 completed.
you write faster than I read.
Yeah, but when I'm writing, I'm spending all weekend on this project. So Jenny will be happy when this is done, but she sees the end date. But chapter 12 is the proof of the feeds algorithm. So we discussed feeds on the on the show, and demonstrated how you can take a specification and then break it up into multiple feeds, and then showed with Jinaga that you call when endpoint, give it the specification, and it gives you back a whole bunch of URLs, and those are all separate feeds, and then you can call get on those URLs. And so this is kind of going under the covers. What is it doing when it does that? How do you take this one specification and turn it into feeds, and why? So what's really fun is that I'm explaining the algorithm and the proof at the same time.
Okay.
So I start with what's the claim? What is the proof actually trying to say? This kind of goes back to CRDTs. So with a CRDT, you've got internal state, and then you've got a function that they call query that can project that internal state into something that the application cares about. And so the claim for a CRDT is that after two nodes have received the same updates, then query will return the same results. Now, the way that the paper proves that is to prove that they reach the same internal state, and therefore any deterministic query function is going to return the same results because the internal state's the same. And then now you take that and you say, okay, the whole database is a CRDT. I don't want the whole database to reach the same state on your mobile phone as it does on the server. You're only interested in a subset. So that means I had to expand upon the promise of CRDTs and say, okay, it's not because the internal state's the same. It's because you know what the question is. You know what query does. And so therefore, you can determine the subset of the internal state that you do actually care about. And so then I walk through the simple case and say, okay, for this simple case, I can prove this, but that simple case doesn't do existential conditions. Okay, let's bring that in. Here's a slightly more complex case. Show you the example, prove that if you do this, then you'll get all the information you're interested in. Oh, but positive and negative existential conditions and projections and what was the last bit? Oh, yeah, multiple parameters to your givens. So basically adding more and more complexity until finally you've seen everything that you can express in a specification, and I've got an example of each one, and then a proof that in general, if you do this, you're going to get what you need, and demonstrate doing that with that example. But the proof shows that it's general, and so by the time you're done, okay, any specification can go through this process. So that's a fun chapter.
Looking forward to see the result of your weekends and weekends work.
Yep. Yep. I should have that one ready for you to look at this weekend. But yeah, you've got a little bit of work to get through.
I still have 5, and after that 6, 7, 8, 9. Mm-hmm. So I should speed up a little bit.
Yeah. Yeah, but then chapter 13 is about query inverses, which were covered in the first edition, but they were covered completely wrong. I introduced pipelines in order to do inverses, and nope, that's the wrong tool.
It's a good idea, but it didn't work out very well.
Nope, not at all.
Not everything can be right from the first time.
Mm-hmm. Yeah.
Because it's amazing if you look to historical modeling, how the whole thing fits nicely together.
Yeah. Yeah, and I didn't know starting out that would happen. I didn't have any assurance that would be the case, but I did it anyway and followed the math, and it's like, oh yeah, look, it does.
If I look back to the first Pluralsight courses, where actually the whole specification language was built into the programming code, that was because at that time you generated even code on the early specification language, if I remember well.
Yeah, for the Pluralsight courses, I didn't bring in correspondence. Correspondence did the code generation, but yeah, the Pluralsight courses on occasionally connected mobile apps, they basically built. They showed you how to create a historical model and then build the communication and the storage so that this would happen, so that it would work. And then you have to just manually do this work knowing the domain. So you have to reapply these same patterns and theorems over and over again throughout the domain. Yeah.
What the runtime is doing today had to be done manually at that time. It was.
Yeah, and also on the feeds chapter, this kind of brings up one of the huge differences between what what I showed in that Pluralsight course and what the runtime is doing now. So in that Pluralsight course and also in the first edition, I talk about pivots, where you find a region in the model where some arrow, some edge in the graph crosses from one person's responsibility to somebody else's. And so those two people, those two actors, are working on different machines, and therefore, this machine is interested in stuff that happens over on that machine, and that edge is the pivot. So, how do you account for pivots in your model? And so, in the in the course, and also in the first edition, I talk about turning the pivot into a queue that now the successor side is checking this queue for information so that it can find the predecessors. And then I talk about queues and topics. In fact, that first one, you could use either a queue or a topic. Topics work well there. But then successive parts of the conversation, then you want queues because you're going specifically to that that actor. So I know that the example I give in the book is the call for speakers, the conference organizer. So the conference can just post their call for speakers to a topic. It could be an RSS feed, and then speakers can see that because they subscribe to that feed, and so everybody gets it. Oh, there's a call for speakers, and then they post their proposal, and now the organizer has to get the response, accepted or declined, back to that specific person. So when done in the real world, that's like email, but it's directed. But in the example, I say, okay, we can put that on a queue. So the speaker that gave the proposal also creates this little queue and says, okay, here's the proposal, here's the queue for you to give me the answer, and then the answer comes back. And so you can take those pivots and then design topics and queues from them. And what the runtime is doing is it's taking the specification and turning that into feeds. And feeds act a lot like topics in that they've got a bookmark and you can read from them. But as you get further on down, you get to topics that only certain actors are interested in. So there's a topic specifically for successors of this proposal. So I'm the only one who's interested in that proposal. And I haven't yet, actually, this is something I need to do this weekend, is I need to tie topics back to distribution rules. That's a really important relationship there. Because when you express the distribution rule that only distribute the accept and reject to the person who made the proposal.
Yeah, and not to the other authors.
Yeah. So that distribution rule ends up being attached to that particular feed. So now when you request to that feed, it says, well, are you that author? Okay, yes, you are. Then I'll give it back to you. You're not? Nope, I'm not going to give you anything from that feed.
Okay, and that's for the moment not covered by the distribution rules.
Right. Yeah, so I've already written the chapter about security, so I showed how distribution rules work. But now that I'm writing the chapter on feeds, I have to make sure that I say, call back to, okay, distribution rules, this is where they come into play. Yeah.
Because in the new chapter 4, you also talk about these pivots, that you see them as an API or even a notification point.
Yes.
But the queue was gone, if I remember well.
Yeah. I think in chapter 4, I'm trying to avoid really specific, detailed implementation type of language. So that might be the reason for that. But yeah, I think it makes sense while you're doing the analysis. You should just be talking about the model and not so much about how the machines communicate with one another. But yeah.
Great. Did you do any further programming last week?
I did, yes. Yeah, so we're halfway in, and uh, yes, I have released a new major version of the three JavaScript libraries. So Jinaga JS. I think we're at version well, yeah, we're at a .0.0 version. Yeah, so I think it's 6.0.0 for Jinaga JS, 5.0.0 for Jinaga React, and Jinaga Server, like 3.0.0, whatever the next major was. But the big change is that I have finally ripped out the template function support. So I was maintaining that for a few versions, yeah, after getting specifications in there, because I wanted, just in case somebody was using uh, the Jinaga JS library, that they would have a path to upgrade to the latest just before the next major, and have both, so they could take their existing template code, switch it over to specifications, and then they could take the upgrade.
Okay.
So yeah, I was primarily thinking about myself with the Improving You app, and one of my coworkers had started building his own app using Jinaga, and so he started with template functions. I actually ran a few ideas past him for how specifications can look in TypeScript. Yeah, so he has since put that on hold, so he may come back to it. But yeah, that was primarily for me and for him. But if there is anybody else out there who's actually deploying something on Jinaga, I can't imagine that there is without me knowing, because how could you be successful without asking a whole bunch of questions? It's like I run
Yeah.
into things all the time, and it's like, oh yeah, I have to figure it out myself. So yeah, somebody's going to run into it, and they're not going to do all the research to look at the code. They're just going to say, hey, your stuff doesn't work.
No, I think for the moment, even with the book and all the videos, you need you still will have a lot of questions.
Yep. Yes, indeed.
Michael, one of the questions, the last meeting we were together, it was about the login, the authentication.
Mm-hmm.
And so I was really confused by the logging in from the client application
Mm-hmm.
and the logging in from the replicator. And then we went through all that handshaking.
Mm-hmm.
But in the end, I was wondering why, because in fact you are doing two authentications. You are
Mm-hmm.
authenticating the client application, the replicator, but also the replicator
Mm-hmm.
towards Google login.
Yeah.
Why this? Because
Mm-hmm.
perhaps it's a new standard way of working, but I didn't find it in the standards.
Yeah. Well, the first and primary reason for doing it that way is that I wanted to have one token, no matter which identity provider you used, one token that you can use for all of for the replicator. So logging in with Apple versus logging in with Google, we exchange the Apple token or the Google token for this replicator token, and then to be able to support additional identity providers. So yeah, I wanted to kind of compartmentalize that identity provider code. So that was the primary reason for that. Yeah, that's that. Then kind of the secondary, is all of the things that could happen if you do rely on somebody else's token. So refresh. So if I rely upon the Google access token, that means that the timeout that's associated with that token, I have to respect in the replicator. And then if there's a refresh, I have to go back to Google with the refresh token in order to get a new one, and I have to respect that refresh timeout. So that means that you'll have different refresh logic and different timeouts for the different identity providers. So yeah, that was one of the practical things
make
that
everything uniform.
Yeah.
Okay.
Yep. So at the moment, it's not even configurable. I may make it configurable at some point in the future, but I really need to see a good motivation. Okay, why do you need to configure this? So the timeout for the access token is 1 day, and the timeout for the refresh token is a month. Or was it 30 days? Might have even been 90 days. I made it. I kind of went back and forth between those two. I don't remember what I landed on, but I was thinking, okay, the way that you're going to use this access token and refresh token is you're going to be. It's basically your stand-in for the for the user of the application. So they're using your application for a day. They want to just be able to keep using it, and then if they stop using your application, but come back within a month or 3 months, whichever I settled on, then that should be just let's pick up where we left off. But if they're gone for longer than that, then it makes sense to like let's just start over. So yeah, I kind of picked those things based on how people would use mobile applications, how people might use progressive web apps, and then I was able to integrate that with the offline cache. So in the Jinaga.net client, it caches the access token, caches the refresh token, and it also caches your public key so that it knows which user fact is you. So when you're offline, it's just like, okay, I'll keep on working and recording things as if you're that user fact. And then I could just kind of synchronize all of those caches. So it's like, okay, I know that the expiration date has been reached for the refresh token, so let's just throw everything away and have you log in again. So I don't even know who you are. I'm not even going to show you offline capability. It's like you have to log in again. You've not used the app in a quarter.
But I think if you set it more than 30 days to 90 days, that's perfect.
Yeah. I think actually that is what I ended up on. But yeah, I'm open to any compelling reason for changing those timeouts on an application by application basis. But right now, I don't really see the motivation.
I set some retention date for databases for synchronization to 3 weeks long ago, thinking that nobody has more than 3 weeks holiday in one time. I regretted it afterwards. You should at least have a month, and I think 2 months and even 3 months is not bad.
Yeah. Okay. Yeah, I'll double check that I did set it to 3 months. But yeah, I think that is where I ended up. Yeah, that does make sense.
Because people go on holiday. Here in Europe, it's regularly 3 weeks, even 4 weeks. Couple of days before they go, they don't use the application. They come back, they do a lot of other things, except using the application.
Yeah.
Like people who work in accounting, they might be using it just once a month for TVA declarations. So you have to cover a longer period than just that.
Yeah, that makes sense. But yeah, I don't want every application developer to have to think about that question. So it's like, start off with it's not even configurable, and then somebody complains, okay, let's make it configurable with default, so most people don't have to think about it. Yeah, I want people to think about more important things.
All right.
Yeah. So other interesting news is that Improving has started their first project using Jinaga. So
Okay.
yeah, this is pretty exciting. So yeah, we got this request for a proposal, and it basically was, offline mobile application. So yeah, our sales team is quite familiar with the work that I've been doing these past several years, and so they're like, this seems like a Jinaga thing. So what would this look like? And so yeah, we kind of went back and forth with what are the different replicator mechanisms. You can do replicator as a service, you could do a Docker container, you could do a node application. This particular client, they're all on premises, so they're like, okay, node application, that check, all right, that satisfies that. There's integration with some other APIs. What would that look like? Oh, that would look like some services that are clients of of that local replicator. So kind of describe what that would look like. All right, check. And then, how would we write the mobile application? Well, we've got Maui and we've got React Native. I've been focusing a lot on Maui because I've got a friend who's rebuilding an application in .NET, and so that one is closer to real time than the React Native. Okay, we'll do it in Maui, and everything just kind of aligned. Gave them the proposal, and so they have signed the SOW, and I think the most exciting part is that I am not on the team. So
Okay.
that means that I get to see another team. I get to see what problems they have with the library. I get to see where I need to shore up documentation. Well, I need to have some Jinaga.net documentation. Yeah, so far it's just the videos,
Yeah.
and then I get to kind of help them out, but still watch and see what works and what doesn't. So yeah, I will. This is perfect timing because the book is just about just about done, and I can start to focus on fixing any Jinaga defects that they find, and shoring up the documentation there, and so yeah, I think this is going to be quite a good experience.
Yeah. I'm really wondering about the data structure independence, because that's still one of my questions.
Mm-hmm.
The moment that you update your structure, what will be the consequences? Because it looks very nice. We discussed a few possibilities, but I really want to see that in practice.
Yeah. Well, funny thing is, in the video last week, I actually ran into exactly that, and I don't know why I didn't run into it before, but yeah, in Jinaga JS, when I added a new field to an existing fact, then I tried to do all the right things in order to make sure that I could read the old or the new model, and it failed. So yeah, I actually did this week find that problem, and I fixed it. That fixes in the new version, but yeah, that updating the shape of the model is is a real thing, and yeah, I'm testing that out right now in JS. In .NET, I have not repeated that same test. What I really want to do is take this chat model and build the .NET version and kind of evolve them side by side and see those same problems emerge in .NET, because I haven't even built that capability into the .NET library yet. But the I know that's one of the things that this team is going to run into. So I've got to get that mechanism put in place. But yeah, I want the capability of declaring more than one record type with the same fact type, and then use structural versioning inside of the library to say, okay, these are the fields that I got. Which one of these C# record types most closely match this particular set of fields? And then I'll serialize that one.
Okay.
Yeah, so then you have all of the records implement the same interface, then you can use them in the same way. And I think that's going to work out, but have to prove it.
Well, because I think that's going to be one of the major advantages of Jinaga.
Mm-hmm.
Apart from the fact that implemented in Jinaga automatically means implemented in the correct distributed way.
Mm-hmm. Yeah, that's the big one. Properly handling versioning, that's a really big follow on. Supporting both .NET and TypeScript clients, that's a big one too. So yeah, and then supporting the end user use cases and the back-end use cases. I have not seen any other library in this space that is going after both of them the same way that I am. So like Firebase, it's intended for end users. It's not really optimized for having a Firebase client be part of the backend. So they've got like a different mechanism for that. And then that seems to be kind of the general consensus, is that we're going to have this offline database for the client, and we're going to optimize it for that use case, but not really think through the how does that turn into queues and responses when you're calling a third-party API. How do you synchronize with something that's stateful? So yeah, I think the full package. People are going to see, like what happened here at Improving, is that I've sold the idea of the offline mobile application so heavily that that's what they glommed onto and say, oh, that's that looks like a Jinaga app. But in fact, about half of the applications that I've worked on as a consultant, I've been able to apply historical modeling to, and very few of them have been offline mobile applications. So yeah, all of the the web applications that I've done, all of the the back-end integrations that I've done, they all benefit from historical modeling, and I always analyze the problem that way. Sometimes I build it that way, and so a lot of them could have benefited from Jinaga, but I didn't want to take that risk on behalf of my client. Say, okay, I'm going to build it in a way that I know that I can pass it off to you, and then you can find people who can continue working on it. But
this is the first time that it will be 100% Jinaga.
Yeah. Yeah. And since they're only taking a dependency on the open source Jinaga, they're not using Replicator as a service, then I've got some confidence that that when they take it over, they will be able to own that. Especially when left with proper documentation. So I got to get Jinaga.net, the website, up and running soon.
Yeah, that's but it's gonna work. That's clear.
Yeah.
I think they're still gonna pop up a lot of small and perhaps bigger things.
Mm-hmm. Yeah. There have already been some questions about data retention, for example. That it's like, I have a theoretical answer for that. I haven't built that into Jinaga.net, and some of them haven't even built into the replicator yet. But yeah, I know what the answer is, and so it's like, okay, after we know that this information has been processed on the mobile application, we want to clear it out. Keep the storage cost low on the mobile device. Makes perfect sense. I've got a plan for that. Haven't built it yet. So, in fact, I talk about that in Chapter 6 of the second edition. This is how you do that. So yeah, I just need to build that API for you so you can call it once a month and say, yeah, okay, go ahead and rotate the database. All right, you done that? All right, good. Let's keep going.
Okay, that will be that solution where you have a database, you create a new one, and from that one, from that moment onwards, you store everything in the new database.
Yep.
Yeah. Okay.
Yep.
What was it called? The train was like an train interchange pattern, or?
Yeah. Train switch. Yeah, that's what I called it. Yeah, so ignoring the fact that you have two axles on a car, and you could actually switch right in between the two axles, and that would be bad. But if that weren't true, then you could switch, and then a car would just go down one or the other, and you don't have to. So you just now go to this one. Okay. So yeah, that's the pattern that I want to build into Jinaga.net, so that you can just call one function at the start of your application. Say, okay, switch it over to this database, and then as long as the queue is depleted in the other one, then it can delete it.
Everything you didn't use the last 12 months, throw it away.
Yep.
My office would be nice.
Yeah.
If I apply that pattern.
Yeah, well, in order to truly do it, you have to move to a different office every 12 months, so that you could then just burn down the old one and then have somebody building a new one, and then you just move to that one.
Yeah. No, by the time you are used to the new one, you have to move again.
Yeah, and then every time you can't find something, you have to get up, go to the old office. Oh, there it is. Move it to the new one. So that way, the only things that are left in the old office are the things you don't use.
No, it's a perfect pattern, but I'm scared to bring it into practice.
Yeah.
Even if I say the things that I didn't touch for the last 10 years, I don't need them.
Yeah.
But
that time frame will be completely in the application developer's control. No defaults. You have to choose when you're going to roll the database. Yeah.
Yeah. It's amazing. If I see in like WSP, that's the version on PC for worksheets, WSP Worksheets Professional. So there I started with replication, I think in 2003 or 2004. And so I thought, at the moment the database is gonna be too big locally. Or if you initialize a new client, you have to copy over all the data. But it turns out that the wireless connections, the 3G, 4G, it always goes faster. The disks are getting bigger, the computers are getting faster, so you really never reach that limit.
Yeah, that's nice.
So,
yeah.
And from time to time, you still have somebody who wants to run a query over 20 years. So,
yeah,
I think it's only in informatics it's not a problem. In cleaning up an office, it's a problem. Office space is not growing exponentially.
No, they haven't. They haven't. Oh goodness, what was the name of that law? Every 14 months we double.
The Intel guy.
Yeah. Well, they haven't got that law for physical spaces yet, so.
was a guy that worked at Intel.
Yeah, getting old.
Yeah.
We forget those. Yeah, that brain is the previous one. I woke up with a new one this morning.
I haven't used that name the last 10 years, so I can forget it.
Yeah, exactly.
Mm.
All
All
right.
right.
Well, welcome back. Yeah, and thank you again for
Yeah.
reviewing the book.
No, it's nice. I should only spend some more time on it. No, I like to read and because it's for me an occasion to reread and to understand it better. Because reading again an old book, you think, oh, I know everything, but
Yeah.
that's not. And a new version is more encouraging.
Yeah.
But it's really fascinating. All the thought that goes into all these years of development and how everything fits nicely together.
Yeah. Yeah. I'm still surprised by that. And I didn't get that sense after finishing the first edition. It's like there's some gaps here. The Querian versus the pipelines. They just like that doesn't quite feel right, and I figured out why. Yeah, it was giving me a little bit of unease. It's like, will I be able to bring this theory back together? It seems to be working, but it's like yes, it all fits.
It's a little bit like mathematics in general, eh?
Yeah, precisely.
Why does it all fit nicely together?
Uh-huh.
And if we would start over the civilization all again, would we end up with the same mathematics, or would it be completely different?
I don't even know how to answer that question. That is,
it's amazing.
Yeah.
It's like why the English people why we count to 10, and England they have a system based on 12. Yeah, is it that their coins, their pound, is it still
yeah, I guess you're right.
1 pence and one? I
Um,
always use euros, so
yeah, there are different counting systems that are kind of like the 60 minutes in an hour. Yeah, that's
why?
Yeah.
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 Why did we end up in that way and not just in a normal decimal system?
Yeah. Yeah, we are going over, but I do remember I just read a book called Hail Mary by Andy Weir, the author of The Martian, and in this book he's well, if there are anybody who hasn't read it yet, you can stop watching now. But in the book he the protagonist meets an alien from a different civilization that their primary sense is sound, not sight, and so all of the physics that arose from us studying electromagnetic radiation and Maxwell's equations and even Einstein's general relativity is all based on the speed of light. And they didn't find light to be terribly important, so they didn't study that. And so
they went to mechanical waves, sound waves.
Yeah, which you don't have access to out in space, but yet they needed to become a spacefaring race. And so even things like, as they are accelerating toward this distant solar system that they need to get to, it seems to be getting closer more quickly than it should because length contraction. And it's like, oh, wait a minute, let's slow down. So they're just kind of feeling their way through general relativity in order to get there. It's like, so what physics and mathematics have we found to be important because of our particular senses? The fact that we can see the stars. We don't live under the sea. Dolphins wouldn't be astronomers. the fact that we have a moon that is accessible, just one
Yeah.
moon. What does that lead to? So, yeah, fun stuff.
It all depends on the circumstances.
Yeah.
Mm. Good. But let's focus on Jinaga for the moment.
Yes. We have this problem to solve. All right.
Because Jinaga has to work before they go to Mars. Yeah.
Oh yes. Yeah.
Yeah.
Absolutely.
Because then we really have a distributed system.
Uh-huh.
Mm.
Yep. I am looking forward to Jinaga in space. It will happen.
Yeah. Might be faster than we think.
Yeah.
Good, Michael. I will be reading chapter 5 then for next week.
Very good.
And looking for the video of last week, which I didn't do yet. And so
Sounds good.
trying to get a little bit more healthy again.
Yeah.
Yeah. Okay. Thank you very much.
All right.
See you next week then.
Yeah. See you then.
Okay. Bye-bye.